AI Portal, number 11. Propelling computer vision with database services. Over in the data science section, we have our database services because that seems to be the best place to put them right now. In context of the way the portal is evolving, we can go out to the cloud. There's our OSCAD console. We can look at our on-prem database services. We have a screen to create new databases. We can add tables to an existing database. You drag and drop the files here as we add all the data to the portal is drag and drop right now. We can build custom pipelines to put things right in the database. Or the vector store, SQL queries, and pie graph generator. Unfortunately, we can't make all the complexity go away. You still need to know a little SQL, at least to use this part of the portal. Going to look at Baltimore real estate data. And we're going to look at a table called January 07. And this has the sales data from January 2007. You got to enter the whole query. You can't just enter the data set here. Always something to learn in SQL. There we go. And so look in the subdivision column in this particular table and fetch those records. And so here's our count of records with none available. This neighborhood Canton we look at is 213 entries. Federal Hill Historic District 210. And so now let's go over here and generate a graph so that we can see the residential home sales by subdivision, and we get the percentage here. None available, 62.9%. Later on, we're going to look at some machine learning techniques because we can probably cut this by half. We know the street addresses of the houses that were sold, and we can put them in one of these neighborhoods or into another subdivision. Either way, there's too much data here to not get it organized here. So anyhow, so we generate the graph in subdirectory images. We're going to save this to January 07 graph, and it'll be a JPEG, and we're going to save the file, and it has saved it successfully. So this is good. Let's go back up here to our query, and we're going to look at the cheat sheet here. We have a table with data from January 2014. So we'll go ahead and copy and paste that in here. And we go down here to the bottom where our buttons are. We can rearrange this. Run the query, generate the graph, and we see that there's only 58% that's not available here. So in this data set, we're getting a little bit better. So you can see it from our table January 14th, none available 1097, and we have a slightly smaller percentage here. So we're going to go ahead and save this in our images. January 14. Gotta be careful with this stuff. Save our file. January 14 is saved, and we just have one more that we want to look at here, January 22nd. Or January 2022. Each data set is a couple months out of the year. So we'll get into that. We're going to run our query first, and then we'll have anyway, different numbers. Let's go ahead and generate the graph. Graph generated successfully, 53% none available. So this is something interesting that we will want to address at a later time, because what I want to do here is go ahead and save the file. We'll go out here real quick, and we have January 22 graph. It indeed works, 53%. January 14 graph, 58%. And January 7th graph, 62.9%. Now, this may not be a high-end computing vision exercise, but we do want to go back over to our RAG and chat, because now we have some stuff that we want to look at. we have a collection of documents. What are the first steps we beginners should take on our computer vision project? And let's see what it comes back with. And let's see what we got. We got a nice full explanation here, and we'll read aloud for just a few minutes.
What a great question. As a beginner in computer vision, I'd recommend starting with some fundamental concepts and building blocks. Here's a step-by-step guide to get you started. Step 1. Understand the basics. Familiarize yourself with the basics of machine learning, deep learning, and neural networks. Learn about common image processing techniques, such as filtering, thresholding, and feature extraction. Step 2. Choose a framework or library. Select a popular computer vision library or framework like OpenCV, TensorFlow, PyTorch, or Keras. Get familiar with the API and syntax of your chosen library. Step 3. Start with simple tasks. Begin with simple tasks like image classification, object detection, or segmentation. Use pre-trained model.
All right, she took the words right out of my mouth. We're going to see TensorFlow up in the future, folks, and that's probably a good way for us to get into our computer vision aspects. Thank you very much for your time.